So in today's Tech Nibble, we're going to be talking about AIs being used to write the next generation of AIs. Now, what's the context here? Now, some people now are starting to use AI in the normal process of developing software. So you're a software engineer, you are part of a team, but you also use AI for writing the code as part of your normal thing. And you might use Claude Code, you might use Codex, and there are other ones, Open Code, and so on. Now, of course, if you can do that for normal software, for whatever it is that you're writing, web front ends, whatever, you can also do that for AI. And in fact, that is what OpenAI have now said that they actually do. They are using the current generation of AI to optimize the kernels that run on the GPU. That's the bit that does the actual mathematics, so that they improve the performance. In fact, they've gained 20% performance. Let me read you a quote. GPT 5.6 Sol rewrote and optimized our production kernels, the core code that executes the mathematical operations that make up the model. So that's for the inference stage, so they get better performance out of the end product that's running on the big GPU servers ready to serve to the public, but it can also get used during the training stage. Again, another quote. GPT 5.6 Sol launched and monitored the training process, intervening when issues arose, including hardware failures and training instability. The resulting improvements increased token generator efficiency by more than 15%. Now, it isn't only OpenAI that's doing this. Almost everybody's probably doing this up until now. Anthropic is doing it. For example, Moonshot, who just released Kimi K3, in a video call with Together AI, who provide hardware services for running AI models on them, they quoted and they said that they were using Kimi to optimize the kernels that were running on the GPU. Very similar to what OpenAI has said. So again, let me take this as a quote out of a YouTube video, so I'll read it the best I can. There was lots of ums and ahs and all that kind of stuff, but this is basically the essence of what they said. The whole model bring up process is a lot of iteration, bringing it up, testing it, running it through benchmarks, looking at performance, and then iterating. The models are starting to become good enough that you can set up these agent harnesses to start to optimize themselves in terms of inference and to bring up themselves, run through benchmarks, get performance results, take a trace, and look at what kernels are running and where the bubbles are and what could overlap more. So there we can see the models are being used for both the training stage and the inference stage. Of course, the next logical step is that the amount of AI time used to developing the next model will increase. At the moment, let's just say it's 90% human and 10% AI. That will start to shift along until you're basically almost getting autonomously the next AI model being produced by the previous one. And it will be given charge of all the training and all the data and the architecture and the size and the layers and all that kind of stuff. And you would say, go and make the next generation. Now, of course, that's great in one sense. The danger, of course, is that you get to that moment of the singularity where the AI can basically reproduce itself better and better, gets faster and faster. Now, the balance to that is, of course, the training stage at the moment takes months and thousands of GPUs, and it takes a long time. You can't just train one up overnight. So it's not like an AI can spin up a new version of itself tomorrow, which is 20% better, and then tomorrow the next one is 20% better, and then the next one's 20% every night. It takes months to bring these up, but that is the direction we're aiming, where AI model creation is in fact a job of previous AI models. Okay, that's it. I'll see you in the next one.